In this video, I will read over the bench this ECU. It's an EDC17CP14. It's from a Volkswagen car. It's from a Passat, and I will do it over the bench. What does mean? I will use only the pinout from the connector and the GPT. Xhorse MultiProg, it can do it in two ways. It can go over the bench or over boot mode. In boot mode, you need to open the ECU and solder one pin directly on the board. I will not want to do it on boot, but I will do the bench mode here. So what I will do, I will connect like always the adapter. I need to find the right pins for this job. But I will do like this. Prepare my box with pins. I will put a positive, a ground. What I will need also, I will need an ignition or a K line. Let me find the right pin for this, right adapter for this pin. 1, 2, 3, 4, 5, 6, 7, 8, 87. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I know I will need two more cans, can low and can high. 1, 2, 3, 4, 5. 5 and 6 will be the can lines. And what I will need the GPT points. Okay, I'm doing GPT, one of them, it's here. And the second, it's here. I will show you also the schematic from the computer. It's provided also by Multi-Prog, so you don't need to look over the internet. But now let's connect. I will need DC power here. I will need ground here. And then I will need S4. S4, where it is S4? S4 should be the green one. I need S4 here. Then I will need S6, which it's showing me it's a blue. I already found it. S6. And S14, a purple. You see S14. And then I will need PVM1 and PVM2. PVM1 should be a gray. P1. Maybe this one? I will put. Oh, P1 and P2. A gray and a yellow. A P2. Okay. These are the connections. I read this ECU before making this video. I cloned and I read with PCM Flash and did the cloning job because the car is remote and I don't want to take any risk when the car is not in my workshop. But I will switch to the computer and show you. The connection to the ECU was made according to this schematic provided by Multi-Prog. It's the same schematic provided by the other tools. So it's the same connection. I will read via bench. If I want to read it via boot, I will need to check this box here, boot. And as you can see here, the information and the connection has been changed. So here you will need to solder and have the P3. This is the adapter which we should use, and use the same pin out, except we will need to solder the boot pin to the board. I will not use boot mode, I will use in bench. I will hit on the read. I had this issue read previously with PCM Flash, as I told you, and we will check the files one by one, but I'm sure the Multi-Prog it will read without any issue. I will read also the internal flash, and I will try to write it. I will write a modified file. So the file I will read with Multi-Prog, I will modify and then write it back. The internal EEPROM, it will take a little bit to be read. The Multi-Prog, it's not the fastest ECU programmer on the market, but it's doing the job. I think that's the most important part to do the proper job. Okay, a new type of loading progress. Data read successfully. Okay, we have some data. I will save this EEPROM on my desktop. Here I have the old files read with PCM Flash, and we will do a comparison. So internal EEPROM. I will hit save. So it has been saved. I will read also the internal flash. I don't know how much it will take, but I will fast forward the video near the finishing process. But if the EEPROM took 3 minutes, 3 minutes and something, let me check again the log. 3 minutes and 13 seconds. I expect to have the internal flash be read in over 10 minutes. But let's see. Okay, almost the same amount of time reading the internal flash as the EEPROM. Strange, but let's save the file. Save on the desktop. It's named internal flash. Okay, both files are saved. Let's do a comparison. This is the old EEPROM, read with the PCM Flash. This is the new EEPROM, read with the Multi-Prog. Let's do the short comparison. So we have some differences. Here it's read at 00 by, in the first file it's the PCM Flash, and here it's the Multi-Prog. So the Multi-Prog seems have been read some extra data from the EEPROM, which PCM Flash was not readed or skipped for some reason. In the main part, it's identical from what I see, and also with PCM Flash I was able to do the cloning process of this ECU, but we have some differences. Let me check also the Flash files fast. So I will load the Flash file from PCM Flash and from the Multi-Prog. So on the Flash file, there is no difference. Both have read in the same way, except the EEPROM, the Multi-Prog have pulled some more data than PCM Flash. I don't know right now, didn't have time to check if that data is needed or useful in some way or not, but we will see. What I will do now, I will pause the video and prepare a mod file for this ECU. Okay, I prepared for this ECU the internal flash. I made a fast egref. I don't know if it's the best solution. I didn't care. It's just for the purpose. I don't have the checksum made, so I loaded the file. This is the file, no checksum. So I don't correct the checksum for my file. The checksum need to be done by the programmer. I want to see if it's working. I can save it. For example, okay, I have it also with the checksum. Okay, but I will go back to the programmer. I will open a file and I will load the first one with no checksum. And let's see what is happening. I will hit on the right. I did not had until now any pop-up regarding the checksum. I hope it will do it. If not, I will need to load the file which I made manually the checksum, or it will be a dead issue and I will need to boot it. Let's see which one of these options. I'm playing with the programmer and with the ECU. Okay, this is not the working ECU anymore. The car have another ECU, and for that reason I have the luxury to play. Okay, Unable to verify if the current file matched the ECU. The file. Do you want to continue writing and take the risk yourself? Let's see. So no information related to the checksum. That means, oh yeah, let's put it. Okay. Okay, writing data. Okay, my advice, when you use Multi-Prog, double check the checksum of the files, because seems not on all cases the programmer is doing the checksum. I know for sure this file had had a bad checksum. So the integrity of the content of the flash was manipulated and not corrected. I just hope I don't crash the issue and I need to use the boot mode or the BDM to recover. It will not be a problem. I can recover it. I have backups, or I hope. Okay. So the chip ID, it's this one, the processor, but in 3 minutes and 51 seconds we write a bad file. I will open. What I will do right now, I will choose the internal flash I loaded and I will hit write. I expect to can write back the original file, the internal flash, but who knows. The ECU have been booted. As I can see the power consumption over the ECU. This is DC power to the ECU. This is power to the device. VCC, VDD and VPP I did not provide to the ECU. I provide only K-line or ignition, how some others call it, but it's a K-line with switch on off the voltage. Sending, receiving, and hope we can write the file. Or it will return an error, we are not able to connect. Let's see. The moment of truth. Checking the logs. So we had the chip ID, we made the connection through the ECU. As you can see, now the ECU has been shut down. I will take the risk. And I hope I will write it. I think that's the reason why the ECU was not killed. Because it's an internal flash. And 3-core, it's still booting until a point. If it was an external flash, maybe I was able to kill it. But that's another story. The key points, always when you use the multi-prog, it's working, but do the checksum with another tool. Or double check if the checksum is okay. Right now, the multi-prog it's not focusing on doing the checksum checkings. But overall, as a programmer, it's very good. As a hint, I used for CAS, I used for a lot of other devices in my daily job on my workshop, where I didn't make any recording, but was working without any failures. So we write back the file, the original file. That's it. If you like my video, please like, subscribe, and see you next time. Bye bye.